video off just to save the data. Okay, so let's start our work. Here we are for geometry. You must have your first session here. Yeah, L1 shows our geometry lecture 1. So first of all, I would like to discuss a few things and then we will start our work. I hope you have received the problem sheet, which contains 15 questions. And yeah, unfortunately, there are 2 printing mistakes by me. Yeah, so I will rectify them. When we come to that question, then we will see what kind of corrections we need to make. So, or otherwise, I will try to put the corrected sheet also. So you will receive that next, that is maybe tomorrow. Okay. Frankly, I can tell you that I just took these questions from my earlier work. And so I didn't rectify. And during the lecture, I tried to rectify, in fact, actually. So I didn't take care about that. Okay. So here we are for our geometry part. You know, in InMo, there are 2 questions based on geometry. And we are going to develop some tools by solving the problems. This is our first day. And so I'm not going to directly start with some kind of stuff immediately. But through the questions, we may go to some stuff, some concepts. And if you have different ideas, then I always like to listen you. Okay. So basically, what I want that here, I consider you know almost our school geometry. This is my consideration that you know everything. Moreover, you know about one step ahead about the geometry, like circles and all. Radical axis and those things are not expected immediately. If you know, it is very nice. But if you don't, then we shall learn that. So you not to worry. Moreover, there are some typical tools, like we extend our ideas, then it is not expected immediately that you know these things, but at least I consider in school geometry that you know what is a point, line, ray, angles, types of angles. Yeah, I'm a little bit faster, so don't look at my handwriting now. Types of angles, then pairs of angles, then transversal, then pairs of angles because of transversal, then you know the parallel lines, then concurrent lines, then triangle, their congruences, their similarity, then you know, say, circle, chords, tangents, and you know something about cyclic quadrilateral. So I am a little bit faster to tell these all. Moreover, you know what is a median of a triangle, altitude, then incenter, circumcenter, circumcircle, incircle, X circles, and little bit about trigonometry. Also, you are able to mesh trigonometry in our problem solving purposes like that. So I expect these things. Before we go ahead, I would like to listen from you that if you have any doubt or any difficulty in any of these parts, then let me know that, sir, I don't know this. I hope I consider you know these all.
So can you just repeat what a transversal is?
Okay. I forgot to
So is
tell.
it when a line goes through two
Just
parallel?
a minute. Just a minute. Yeah, we have one rule. Okay. If you want to speak, you have to raise the hand so that I will understand. Oh, who is talking? So yes, Atharva, go ahead. What you want to ask?
Sir, is a transversal a line which cuts through two parallel lines?
Oh, great. We will listen from others. Who can tell me the definition of transversal? Who is ready? Just raise your hand. Uh, I want the definition of transversal. Be faster so that we can save our time. Okay, yes, Safura.
A transversal is a line which passes through two parallel lines,
Okay,
and that gives rise to many angles.
okay. Yes, Vanya.
A transversal is a line which intersects two or more lines in a plane.
Okay, two or more lines in a plane. Okay. Uh, I think just a minute. I want to increase my voice. Okay, okay. Yeah. So, Kriya.
Sir, it's a line that passes through two distinct lines
Hmm.
in the same plane.
Hmm.
Yeah, at different points, I guess. Yeah, at
Yes,
different.
that is important. So when, uh, so suppose we have these lines, say L, M, N, then L cuts M and N in two different points. So we call L as the transversal. Actually, in transversal, we do not use the word parallel. And it's okay. There is a special case that if two lines are parallel, then we have their transversal. That's a special case. But in transversal, there is no word parallel. Okay, so what I mean over here about school geometry, then I expect you that you must read the textbooks critically and find out the definitions what you find. Moreover, we consider the terms in the same plane. So if we miss the word coplanar, we are not going to bother. But if we use the word coplanar, then it is always welcome because we must be that much particular to tell about the things. So here, while mentioning, I used transversal and after that I used parallel lines. Okay, so that is what the typical definition. We must be like, I may say, we must be precise to tell, and also we must be concise to tell. So precise and concise would be our motto while expressing our thoughts. Okay, and if you miss the definition or any term, don't take tension that if you have any problem, immediately you raise the hand. We will discuss and sort out whatever difficulties you have. Moreover, if you have more ideas than me, then always you try to share those ideas so that we all can learn from you and we can develop our tools to solve the problems. Okay, so that is very important. It is not that what I say is always only the thing. There can be different approaches, and those approaches we will take. We are not going to mesh complex numbers immediately. Step by step, we are going to develop our tools. So basically, we are going to develop our ideas beyond our school geometry. So I expect the knowledge of school geometry from you. It's our first day. So if you are not uh, recalling those things, then don't take tension. You can go through those things during the next days so that you can sort out and also get those things immediately. Okay. Then moreover, I give some worksheets. I call them as worksheet. That is my definition. I call them as WS. So they would be numbered like WS1, WS2, like that. Okay. Then they contain some problems like 15 problems, 10 problems, sometimes 7 problems, sometimes more than 15 questions. So it is not fixed that how many questions I may include. Sometimes there would be some, so there are some problems. There would be some reading search, or there would be some kind of stuff to read. Okay, so what is the difference between reading search and stuff to read? That in reading search, I ask you to read from some resources, then that is your part to read them, and you would be prepared for next session. So now I think whenever our next session will come, then I will give you the reading search. So suppose now this is 18th August. So I may give you in next week so that you will receive the worksheet. In that you will find if there is reading search, you can go through that. Then in advance, I will give you the worksheet so that you will work on the problems and we will discuss their solutions during our sessions, and we will sort out the difficulties where we find the difficulties. Moreover, different ideas will come out because your brain is fresh brain, that you have very nice ideas than me. So I always welcome solutions by you. And if there is stuff to read, then it is that expected that you have to read that, understand. And during our next session, we will discuss that stuff, what I had put in that worksheet. So basic structure of our lectures would be like that. So you will receive the worksheets which contain problems, sometimes reading search, sometimes stuff to read. Accordingly, you have to prepare during those days, and we will meet in our sessions so that we can save our time and we can develop our ideas more or in faster mode. Okay. So moreover, if you are solving the problems and you want to send those solutions to me, then you can scan your that so scan your solutions and make it PDF and send me. My mail ID is already always at the bottom. So my mail ID is this.
Sir,
Yes, who is speaking?
Atal,
Because hand is not raised, so I can't understand who is speaking. I told that. See, there so should be some rules. When three or more persons are there, then we have to follow some common discipline. Yes, go ahead.
so in Google Classroom, while responding to the worksheets, there is an option where we can send private comments to you. So can I send my solutions in those private comments?
Yes. See, suppose I think I am not in that classroom. Suppose. Okay, then I am not going to receive that. Then what to do? My mail ID is there. You can attach that file and send it to me. Okay. In time, I will grade that, or I may do some comments on it and will resend you. Okay, so it is for all that whatever problems are there, it is not necessary that uh, you expect the solutions of all questions by me, because it is not possible to have solutions of all problems. But if you think and if you put your ideas, then it is always better. Moreover, don't take tension if you are unable to solve the problem. I am also unable to solve every question. Okay, so I also struggle, and that struggle develops our thought process. So I expect the same thing from you. Okay, so whenever you have um, uh, time, work on these sheets and try to send me as soon as possible. I always try to uh, reciprocate to you. Okay, so among the sheets, suppose there are 15 questions and you work on 10 questions, 5 are remaining, then we can discuss those 5 questions here so that we can save our time. Moreover, the different ideas, if I like the solution, I will share that solution with you all. Suppose one person has different ideas, then those ideas will be shared to you so that you will have different approaches to the problem. That is very important, not necessarily only by one method. Okay. Uh, for this, you need to prepare one notebook. I do not force you to make the separate notebook. If possible, you can, or you can keep one notebook for this course. No worry, it is your lookout. But whenever you write the solution, I always insist to write the problem and then its solution. Try to draw better figures, and you are allowed to use GeoGebra or Geometry Sketchpad like tools. If you have Texas Instruments, graphing calculators, then that is also welcome for visualization. But I ask you not to take help from any immediate sources from artificial intelligence, because in exam we do not have such sources. Yes, Atharva.
Sir, am I allowed to write my solutions up online on some sort of notepad or something and send it to you?
Yes, you can write in, if you are able to write in LaTeX, no worry. I want PDF, that's all. So
Sir,
however
not
you can write.
necessarily PDF, like handwritten notepads.
Yeah, you write notepad and you can make it PDF. That is very simple.
Yes, sir.
Yeah, very simple question asked by Shreya, that are the questions supposed to be done in order? No. Whatever you are okay or feeling better, you are allowed to solve any question. You are allowed to send me solution of any question. Apart from these, if you have any extra questions and you want to ask, you are welcome. Okay, so don't think that only through worksheet you are allowed to ask any extra question. Okay, so it is not that very rigid, only you follow the worksheets what here you are receiving. You are allowed to work with extra questions if you have, that is also welcome. Okay, for better start of geometry, I think, oh, here is the question. I can just suggest some books that you must have. The first is School Geometry by Hall Stevens. Then there, I call it as, I shall write in short, Challenge and Thrill of Pre-College Mathematics, and Problems in Plane Geometry by Sharigin. So these books are more than sufficient, I hope. School geometry contains our plane geometry, solid geometry. I think solid geometry is not immediately required. You can just deal with the plane geometry. Challenge and thrill of pre-college mathematics contains chapter 3rd, 4th, and 5th on geometry, which has plenty of questions so that you have many questions from that. Yes, I adopt or I take questions from such books, or I take questions from some competitions from all over the world, which we discuss over here. Sometimes those questions will be reformed or some kind of refurbished. So some changes by changing that I may try to put, so that you rely on worksheets as well as other resources, whatever you can. And eh, whenever you get time, you are solving them. Then if you want that, what kind of your solution goes, you can send me by making it PDF anytime. Okay. So I think um, no one has any question in this context, as it is our first time we are meeting here. So I just explain few things over here. Before we start, if you have any question to ask, if I miss something, then you can ask. Yeah. Yes, Atharva.
So, do you know any good contests which are good preparations for INMO, like good contest collections?
I think it is better to take the last year's question papers. That is better idea. Last year's question papers of INMO and RMO. I think if you take those question papers, that is good. Art of problem solving has so many contests in that. You can check over there. Okay. So you will get so many things. Yes. Yes, Kriya.
Sir, about like the books, like I have challenge in field of mathematics. How often should I solve the problems? Like how many problems per day?
Yeah. See, if you read the question and you figure it out, okay, what is happening in that question, then no need to immediately work on that, because some questions are immediate. If you read the question, you will feel that, okay, it's done. Now in this worksheet, I intentionally put the questions in not graded order, like first simpler, then difficulty level is increasing. No, I put them in random sequence. So you may find few questions are numerical experiences, few questions are not. I intentionally try to put some numerical experience that just to have some kind of dealing with numerical problems. So intentionally, I put 1-2 questions in that. And in challenge and thrill, there are so many questions. Okay, so you try to work on them, and you try to get the idea. If it is obvious, don't work in your book to save the time. Okay. So yeah, Shreyanza has the question that can we use coordinate geometry? Yes, you are allowed to use coordinate geometry, but in INMO, the most elegant solution goes if you do not use coordinate geometry. Okay, because if you use coordinate geometry or if you use complex numbers, then the problem is more algebra than geometry. So your geometry skills, like you can use homothetical ideas, you can use some kind of uh, next ideas like inversions, or you can use the translations, different kind of transformations that you can use more. You, if you use that, it is good. So coordinate geometry is a good tool, but I always try to keep myself away from coordinate geometry. But if you are able to solve by coordinate geometry or by using trigonometry immediately, then yes, you can. But I think trigonometry is a nice tool many times. So we are allowed to use trigonometry better in our problem solving. If we are not able to get solution by our classical geometry, then you can opt for coordinate geometry, and you can also go further. Sometimes not in InMo, but in next level, we may require to use that complex numbers and all. Okay. So it is, I am not going to make you restricted that don't use. You are allowed to use. And if you have such ideas, put those ideas here so that we will share to all. And those persons who are not able to mesh coordinate geometry in that, they will also learn. Yes, Atharva, you have question? Your hand is raised.
Sir, is Challenge in Thrill of Pre-College Maths written by BJB CR
Yeah, yeah,
Pranesh?
yeah.
Sure, okay.
Yeah,
And who are
Praneshachar,
the
then DJ Venkatchala, CS Yogananda, and Krishnamurti. Those are the writers. Okay. Yeah. Did you get? Hmm. Okay. I hope, Shreyan, I answered your question, and I answered Atharva's question. Any question more than this? Okay. So there are, I am finding some 13, 14 participants. So open up, try to speak, try to share ideas always. Okay. So here we are ready to deal with our problems, and our first question is here. Yeah, I expect that you read those questions and you have your thoughts on these questions. It is a typical question, a very typical question it is. It's a small configuration which deals here, that I will read the question. I hope you have question with you already. Yeah, and because we are online, so we are unable to provide you hard copies, that printouts, but I expect that you will take printouts or whatever convenient for you, but you would be ready for our session so that we can save time. That's all. Okay, so half an hour I took for the instructions, and now we are ready. From next lecture, there won't be any instructions. We will start our dealing with the problems or some next steps. Yeah, so the first question is, in an acute angle triangle ABC, line segment AD, PE, CFR altitudes. H is the orthocenter. Then we need to show that these triangles AEF, TBF, TC, and ABC are all similar to each other. And then we need to show that H is the in-center of triangle DEF. Okay, so we need to draw the figure first of all. It is acute angle triangle and ADB CFR altitudes. Point of concurrence of altitudes is known as orthocenter. Okay, and yes, I hope you know how to show that altitudes are concurrent. So that part I am not dealing here. We are not going to discuss that. I consider that you know the proof how we show altitudes are concurrent. If not, you try to find out. You will get, if you are curious about that. And if you know it very well, there would be different ways to show them concurrent. Any of the ways, if you know very well. If you don't, then I will discuss over here by one or two ways if you want. Not now. First of all, we will discuss about this problem. Now for that, we assume that yes, altitudes are concurrent. Their point of concurrence is the orthocenter of that triangle. Okay. So I would like to draw the figure. I am not good at drawing, so if I miss something, then just try to understand that. So this is our triangle ABC. AD is the altitude. BECF are altitudes. And now triangle AEF triangle DBF. Yes, my hand is hanging because I am not using iPad or something. I have some like touch screen, so my screen is vertical. So it, because of my hands orientation, sometimes it goes. Sorry.
Sir, can I suggest a method for the second part?
Raise your hand and then speak. Always our common discipline. Very simple. Yes. Yeah. Go ahead.
Sir, can I suggest a method for the second part? I'm not sure if this will work, but I think this might.
Okay. What
Sir,
is that?
the in center is
Sorry.
the intersection of the angle bisectors. So
Okay.
if you can prove that BE is the angle bisector of FED, and similarly for the others, you have proved the claim.
Wait. What? Repeat. Say again.
So the in center is the intersection
Wait.
of the
Intersection.
angle.
Wait. Intersection and concurrence. There is small difference.
Yes,
Can
I
you
mean the
explain me?
concurrence. It's
No.
the
Can you explain me what is that difference?
intersection is where the two lines meet. Concurrence is where two or more lines meet.
No, three or more.
Three or more.
Okay.
That's what I
Yeah.
meant.
Go ahead.
The way the incenter is the concurrence of the angle bisectors. So if we can prove BE is the angle bisector of FED, and similarly AD is the angle bisector of FDE,
Mhm.
and CF is the angle bisector of DFE, we are
Okay.
done.
Yeah, but how you are going to show that they are angle
And sir,
bisectors?
we can use the 90 degrees since there are many 90 degrees due to the perpendiculars. This is just an
Okay.
idea. We can find a cyclic quadrilateral and then equate angles. I'm still trying it out, but I think it might work, sir.
Yes, your idea is very nice. I really like that. Okay. And yes, Shreyan.
I think that for part one,
Your voice is very low. Can you come near to the mic, please?
sorry sir, there are certain problems with my mic.
Okay.
I was saying that we can just say that since it's equal axial triangle, ABE and FCA have same angle, right? So and since it's again equal axial, we can just say that ratio of AE to AB is same as AC to AF using trigonometry. Since same angle matlab say, means same trigonometric ratio, and by SAS we can do it for AFE is the same as ABC, and we know, and we can do this for the others by symmetry, and then we are done, I think.
Okay, so you consider it as equilateral.
Not equilateral. I'm saying that since it's right angle, the AFC triangle, AFC triangles, we know that trigonometric ratios are same, meaning that AF to AC is the same thing as DE to AB.
Oh,
DE to
okay.
AB. And then
Good.
we can SAS it, and by symmetry, it's the same thing for DEC, DFD, and therefore we are done for part one.
Okay, so you are taking ratios of sides because of trigonometry. Okay, and which angles you are using?
I am using that, what we say.
Yeah, so angle A is common for FAE and BAC. Am I right?
Yes.
Okay, good. That's very nice idea. Yeah, so yes, Raghav.
Yes, I had more of an angle chasing idea.
Mm-hmm.
So we know that AFHE is concyclic.
Yes, AFHE.
HE.
Okay, yes. Okay, yeah.
Yes, sir. So angle AEF would be 90 minus angle FEH, which is, and FEH is equal to FAH, which is 90 minus B. So then you have angle AEF equals B.
Yes.
So by angle criteria, both the triangles are similar.
Correct.
A angle is common.
Nice. So I will write that ideas over here. That so for showing first, our idea 1 is that use T ratios. Yeah, here T ratios, that is trigonometric ratios, and a common angle, say for triangle AEF and triangle ABC, and then use SS similarity criteria. Okay, so that is what by Shreyan it is said. We can use trigonometric ratios and common angle for triangle AEF, triangle ABC, and symmetrically we can go for their DBF and DEC with ABC triangle commonly, and then we use the transitivity of similarity. So we are done for our first. Second idea by Raghav is that we can merely use the cyclic quadrilateral and angle chasing, cyclic quadrilateral and angle chasing, so that we can get by angle similarity criteria, we are ready to prove those triangles be similar. Yes, Raghav, you want to add on?
Yes, I found a shorter solution.
Oh, yes. Go ahead.
So we know that BFEC is concyclic.
Yes. Good.
Yes, sir. So angle
Yeah.
B is equal to angle
Good.
AF.
Yeah. So in idea 2, I didn't mention which cyclic quadrilateral. Okay. So AFHE is cyclic. No worry about that. And yes, BFEC is also cyclic. And hence we can use that. Almost the idea is same. Yes, Atharva, you want to say something?
So for the method I suggested, I figured out all of the details.
I didn't understand what you want. Can you
Sir,
repeat?
I figured out the details for the proof.
Oh,
Can
very
I?
nice. No, wait. We are just mentioning the ideas and then we may write the proof. So I think here, such ideas, if I mention, you try to write those ideas and go ahead at your own. And if you have problem, difficulty, then ask me. Okay. So which idea now we are going to execute, that you can decide. So I'm not here to immediately say, okay, yes, Shreyan, you want to add on?
Yes, sir.
Hmm.
I was saying that we already show similarity. We know that AFE is equal to ABD, BFD, the angle, right? And since we command
Which one? AFE is equal to angle?
BFD by similarity,
Hmm.
right?
Hmm. Hmm.
Therefore, because of 90s, we have DFC is equal to CFE
Hmm.
and
Just
bisectors.
a minute. Huh.
And then we have done bisectors and I've gotten the answer for the second one.
Yes. So if we are done with first, then second is obvious. Okay, that's very nice idea. Okay, yes. I think we would like to write the solution for it. So basically, my way of working is to get the ideas from you and then develop those ideas. So solution is with you and we will elaborate that thing. I will go with idea 2 first because that is very simple idea. Okay. Why simple? That is because it has no more machineries, no more tools like other than angle chasing. Okay. So solution by following idea 2. From idea 2, we are going ahead. That because angle BFC is equal to angle BEC, since it is 90 degree, therefore we say that BFEC is a cyclic quadrilateral. Okay. Who didn't understand this? Raise your hand. Why BFEC is a cyclic quadrilateral? Raise your hand. Don't hesitate that, oh, okay, I am writing, so let's write down in the book. Don't do like that. If you do not understand, ask me that why is it cyclic? Because see, these I will draw a figure over here. In fact, it goes like this. Sorry. Like that something. Okay. Here is our E, here is our F, here is our B and C. So it is 90 degree, 90 degree. So if you have that opposite angles are supplementary, no, I am not using that part. Okay. So I am using something different. If you are not knowing this stuff, then yes, ask me that why is it so? If you are not, then I consider, okay, you understood this. Great. So all understood. Nice. I liked it. So BFEC is a cyclic quadrilateral. And then therefore, we can say that angle AEF is equal to angle ECB, which is merely capital C, which is the angle of triangle ABC. Oh, that you know, the standard notation for triangle ABC. Okay. So we got that this is our, oh, I think I made a mistake over here. Yes. Nobody recognized, I only recognized. That is EBC, that is B. Sorry for that. Yeah, while thinking. So this angle is B. Okay. Any question? Because AEF is the exterior angle of cyclic quadrilateral BFEC. And so its measure is always of the opposite angle of it. Okay. Yes, Atharva, you want to ask?
How is EBC equal to angle B and ABC?
Oh, EBC I wrote. Oh, that should be a FBC or whatever it that. FBC, sorry. Yeah, I missed that. That should be F. Okay. Yes. Is it correct now? So many hands were raised. So now I think it is right. Okay. It shows that you are paying attention. So that angle is B. Yeah.
Sir, how is AEF equal to FBC?
Okay. Suppose we have a cyclic quadrilateral. Suppose it is a circle. And if we have a cyclic quadrilateral in that, then this is the exterior angle, which makes the linear pair. So this is X, then opposite angle should be 180 minus X. And so its linear pair is X. And so these angles are equal.
Oh, yeah.
Got it? Okay, great. Yeah. So if somebody didn't understand, ask me so that I can tell you. And you try to note it down in your notebook that what is happening actually. Yeah. I am not giving you very exact way of solution. I am just giving you the idea of solution. Okay. So don't consider that, yes, this is only the final solution. I am giving you the structure or idea. Okay. So I am not very much precise writing the reasoning and all. If you want, then I think it takes a time. So, and it is very some typical questions. So I am just hoping faster. Okay. So I hope everybody got this. So AEF and FBC are equal. Similarly, we have angle AFE. That would be equal to angle ECB.
C.
Okay, that is nothing but C And so I can write over there, this is our angle C. Okay.
So you don't need to do that angle chasing. If one angle is A and the other angle is B, by the 180 sum rule,
Yes.
it's
But
C.
for our second part, it is, I think, needed. So I made it. Okay. So similarly, as we work for triangle, quadrilateral, BFEC is a cyclic quadrilateral. And so we could get those angles. Then in the same fashion, we can have that. I will put here just for our knowledge that similarly, we can say that quadrilateral ABDE is cyclic, and then therefore now you look in the figure, where is ABDE? So actually I used the fact that angle AEB is 90 degree and angle ADB is 90 degree. So line segment AB subtends equal angles at two different points at the same side of it. And so these points A, B, D, E are concyclic, or we can say that quadrilateral ABDE is a cyclic quadrilateral. And because of that, we can immediately say angle DEC is equal to angle DBF, which is equal to B, and angle CDE is equal to angle FAE, which is equal to A. So this is our angle B and this is our angle A. Okay. So yes, Satharva.
Similarly,
Hmm.
angle BDF is equal to A and BFD is equal to C.
Correct. So similarly, we get, now here I am going to directly write that angle BDE, oh sorry, FBDF is nothing but A and BFD is C. So this angle is A and this angle is C. Okay. I can give them say number 1, say number 2, and this as number 3. Okay. So from 1, 2, 3, we can say that triangle ABC is similar to triangle AEF. You can just check the one-to-one correspondence. Here, I try to maintain one-to-one correspondence. If not, then it is wrong. So AEF, that is ABC, is similar to triangle DEC, and it is similar to triangle ABF. Sorry, DBF, I'm wrong. DBF, and we use our angle similarity criteria. Okay. Yeah, Atharva is asking that, do you know any website to make a good online diagram? Is there a tutorial? I think I do not know. I draw by hand. I use a scale. I use ProCircle. I use the rounder to draw the figures. Because in examination, you need to draw figure by using scale, rounder. And so I also use that. And I not insist you, but I suggest you to do the same. But for visualization, if you use like GeoGebra and all, then it is better. But if you put input in some program and it is delivering you the figure, then that program is using their brain, not us. Remember, okay? So what I said here, that we need to develop how to visualize. So I suggest you to draw at your own. In exam, we need to draw figures by scale and rounder. It is better to do that. Or if you are ready to visualize and you can draw figure by only scale, okay, no worry about that. But if you draw figure by using the geometric tools, it is very nice always. Okay. So I think this is more than sufficient for all to understand our first stuff. And now second is obvious. I think I am not going to do that. Do you want the solution for second? I think not necessary. Huh? Okay. So in figure, it is immediate that yes, angle ADE, or we can say angle HDE and angle HDF are equal to 90 minus A. Similarly, we can get angle, or otherwise I will write on right corner what I said here, angle HDE is equal to angle HDF. Moreover, that is equal to 90 minus A. We have also angle HEF is equal to angle HED, which is equal to 90 minus B, and similarly for the rest. And hence those HD, HE, HF, or we can say AD bisects angle FDE, BE bisects angle DEF, similarly CF bisects angle EFD, like that. Yes. So because of that, we have immediate H is the in center of triangle DEF. Okay. So Shreyan is asking that many times our diagrams might make additional assumptions. For example, triangle is acute and make us show wrong statement. How do we avoid other than making multiple diagram? Also is freehand okay? Yes, freehand is better always. Okay. Once you get freehand, you can make it by scale, so that in solution, if your diagram is drawn by some geometric tools, it looks very simple or good impression for the grader. Okay. I think not, Atharva. It is not necessary. Okay. For us, it is not immediate part, because we need to solve the problems for the competition. I can't make the bifurcation that it is like computational geometry or combinatorial geometry or what. So I can't immediately bifurcate, because we have to, many times we have proofs, sometimes we have constructions, so we may do them not combinatorial. Okay, exactly. Okay, so from this question, we have some typical idea that I'm going to make some additional remarks on this problem, which are not included in our worksheet. Okay, so yes, sometimes it comes geometrical. Atharva is saying that in 2023, it comes combinatorial geometry problem. Yeah, I think it is that we are in 2023 and you will be appearing in next year. So uh, different ideas are meshed in the problem. So it is not certain that always it comes. Okay, so suppose I have a triangle here. Suppose this is our triangle ABC, and I have any point P inside the triangle. Then if I drop the perpendiculars on each side from that chosen point in the plane of triangle ABC, yes, we are coplanar, unless and until I state. Then we see that the triangle is forming, which is then this triangle is known as pedal triangle of triangle ABC with respect to WRT, with respect to, okay, W that is known as the pedal triangle with respect to point P. It is not that P must be inside the triangle. P can be outside the triangle also. Like suppose I think my internet connection is unstable, but P can be here. Then we can drop perpendicular to the extended sides also. Then the triangle formed by the perpendicular feet is termed as the pedal triangle again. Again, that is the pedal triangle of triangle ABC with respect to the point P. Okay, so that is a pedal triangle. But in a special case, if, or we can say that H is the orthocenter of triangle ABC, then the pedal triangle of triangle ABC with respect to H, that is orthocenter, is termed as the orthic triangle. Yes, is termed as the orthic triangle of triangle ABC. That is the orthic triangle of triangle ABC. So pedal is a general name, orthic is a special case. Okay, so that is our orthic triangle of triangle ABC. If our point P is a special, that is orthocenter. Now there would be some questions like, suppose my I is the point that is in center, then we get a pedal triangle with respect to I. I don't know what is the name and I didn't try to find out, but that is again a typical triangle. Okay, and I plays a typical role for that triangle. Okay, so that is another special case. Similarly, for we may have orthocenter as the point, circumcenter as the point from which we may get some pedal triangle. Okay, so there is one case that suppose a triangle has, we draw the circumcircle of triangle, and we take point P on the circumcircle of that triangle. Okay, so in my figure, I just drew by hand. So circle is not circle. Okay, so I always say that suppose it is a circle. Okay, so suppose it is a circle and point P is on the circle. Then yes, Atharva is ready to tell that what will happen with that.
So
Yes.
when you drop the perpendiculars, the feet of the perpendiculars are collinear, and it forms the Simpson line of the triangle.
Yes. So if we drop the perpendiculars, then we find that these 3 points are collinear. These 3 points are collinear. Yes, I drew by hand, so try to understand. Okay. Then in that case, this is termed as pedal line. because the pedal triangle is degenerated in a line, and that is known as pedal line. We also call it as Simpson line with respect to the triangle. Okay, so a triangle has infinite Simpson lines, obviously. And yes, when we have this idea, then we always ask that why? What is the proof for Simpson line? Why that 3 points are collinear? Why this pedal triangle is degenerated in the single line? How we can prove this part? Okay, so let's prove that. We will prove that how those points, 3 points, be collinear. Okay, so if you know the proof, yeah, you can share it, or otherwise, yes, Atharva.
Sir, I don't know the proof, but can I give a suggestion on what the idea can be?
Yes, there are, I think, variety of proofs, but among them you can. Okay.
So can I annotate on the screen instead?
Yes, you are allowed.
It will be hard to describe with words.
Yes.
Okay, so this point, we consider the two line segments going to this point. Okay. And if it's hard. Wait, let me just rechange the position. If we can prove this line, we consider these two line segments.
Okay, we will give the names. Okay, so that would be better, I think. Oh, sorry. Say this is Q. Then this is R, and say this is S. Okay, yeah, go ahead.
Okay, so we consider the line segments SR and RQ, and we consider the angle they make with the line AC. So the angle they make with this line.
Which angle you can say the name? Okay, ARS.
TRQ and ARS. And if we can prove this angle is equal to this angle, then we can prove that it's collinear.
Okay, so you are using vertical opposite angles concept. Okay.
Yes, sir. And to do that, sir, we can take advantage of the 90 degrees and find cyclic quadrilaterals.
Okay.
And with that, we can do some angle chasing. So one example of a cyclic quadrilateral would be, wait.
Okay. Yes, Sharav, I think Sharav wants to say something. Yes, Sharav?
So we could check whether RS plus RQ is equal to SQ. That's like a standard way to check whether they are collinear.
Okay, that is one part. But I think that goes difficult because P has many positions. And I think it goes little bit tough to deal in that way. I hope. Yes, Raghav.
Yes, so we can consider a cyclic quadrilateral PRSA. So basically the idea of the proof is to show that PSR is equal to PSQ.
PSR is equal to?
Angle PSQ.
Oh, that we need to show. Okay.
Yes,
yeah, go ahead.
If we show that, then we are done. So note that since PRSA is a cyclic quadrilateral, angle PSR would be equal to angle PAR, which is basically angle PAC, which is angle PBC. So this is one part. Now we consider angle PSQ. So since PSBQ is a cyclic quadrilateral, we have PSQ equals PBQ, which is basically PBC. So we are done.
Okay. Okay. Yeah. Shreyan also wants to say something. Yes, Shreyan.
would be better to, instead of proving SRQ, we could show that a point that is intersection of SR and BC will make 90-degree angle with P.
No, I didn't get. Can you repeat it?
You can show that a point which is intersection of BC and SR is 90-degree with P instead of proving it collinear.
Okay, yes. So you mean that SR is meeting BC somewhere, and at that point PQ is perpendicular to BC. Okay, can be done like that. Okay, yes, Atharva, you want to say? Okay, so yes.
Someone mentioned the proof with angle chasing, but I couldn't quite catch it. Can you write the proof down?
Yeah, we are going to write it. I am just listening to your ideas, and I think a simple idea is by using the cyclic quadrilateral is a better idea here, I think, because it is immediately observed. Yes, Arjun?
So can we use like the Menelau's theorem? Maybe if we can prove that like AS1 as times.
Yes, but I think to get those ratios, how can you figure it out? That part, because I think AS over SB times PQ over QC times CR over RA must be -1, or if you consider only magnitudes, then that is 1. So I think it goes a little bit tougher, or I think for that we need to do some angle chasing. And yes, that is also one idea, but it goes a little bit longer, I hope. But that is also one part. We can use the converse of Menelau's theorem that to show the collinearity. Okay, because in fact, SRQ is the transversal for triangle ABC. And so if that typical ratios product is 1, or if we consider the directed line segments, then it is -1. Then we have immediately by converse of Menelau's theorem, those are collinear. Yes, Atharva.
So does the converse of the theorem hold? Meaning if S, R, and Q lie on a straight line, that means P is on the circumcircle of ABC.
No, I didn't get. Can you repeat?
Does the converse of the Simpson line hold true? Meaning, if the pedal triangle of a point P with of a triangle ABC with respect to point P is a straight line, does the point P have to be on the circumcircle of ABC?
See, actually for Simpson line, we need the perpendiculars. Now, suppose I have one figure, just I would like to show you here. If suppose this is the circumcircle, and if this is a triangle, okay, and if I draw this, okay, so I drew the transversal and I drop the perpendicular to this, okay, somewhere here. I don't know, my figure is not exactly right. Then I think from here the perpendicular is not going up. Am I right?
So, but can we prove it? Like
from here also, how can we? So converse is not exactly the reverse idea here, because I can have infinite transversals. So I consider one typical transversal almost as good as our SRQ. But we are not getting. So if so, then you try to prove it that it happens always. It happens always. If we have a transversal, then there exists one point on the circumcircle such that on each of the intersection points.
So you aren't getting my point. That's not my point, sir. My point is, if there exists a point P such that the pedal triangle with respect to P is a straight line, does it mean that P is on the circumcircle? So
Okay, so can you tell me the statement of Simpson line, that what is your statement?
So the Simpson line states that if P is on the circumcircle of ABC, then when you drop the perpendicular of
Hmm.
P onto the sides AB, AC, and BC, the resulting foots of the perpendiculars lie on a straight line. But what my converse I'm asking is, if you have a point P such that the foot of the perpendiculars S, R, and Q lie on a straight line, does it
Hmm.
imply that P is on the circumcircle of that
Yes,
triangle?
we can show it by just using angle chasing. Okay, we can show it by using angle chasing because we use the cyclic quadrilateral over there, and so we show that the angle formed at P, or we typically say that angle APC would be 180 minus B. We can show that. Okay, then we are done. Yes, Shreyan, what you want to say, that a line segment with a point between the edge points. I didn't understand, what do you mean by edge points here? Which edge points you are taking?
I think that we say that it's a pedal triangle as well as a pedal line, right? So do we say that any segment which has point SQ as the endpoint of the segment and R in somewhere in the middle of the
I
segment?
think R is not necessarily always, because if P varies, then QRS varies.
Yes, but
Okay.
if we consider such a line with a point in such a segment with a point in the middle, do we consider it as a triangle?
I think one should lie in the exterior, because if all are interior, then because of triangle, we are not going to get a straight line.
So pedal line is not considered as a pedal triangle.
Pedal line is the degeneration of pedal triangle. Okay, that's the degenerated triangle is degenerated, because P is a special point which is on the circumcircle. So the perpendicular feet from P to every side, not necessarily when we say side, then we are considering the line containing that side when we drop perpendicular. Hmm? Is it correct that what your point you want to ask?
Yes, sir. Thank you.
Okay, yeah. So when we define that what is a pedal triangle, in fact, we consider a point in the plane of triangle, and we drop the perpendiculars on the sides of that triangle. Then the perpendicular feet are the vertices of that pedal triangle. When P is a special point, so what we say that, so for triangle ABC, if P belongs to the circumcircle of triangle ABC, then or we can say that instead of, if I use P belongs to the circumcircle of triangle ABC and PQ perpendicular to BC. Here, when I say BC, it would be line. Okay. Some books prefer here line BC like that. Okay. I am not that much particular, but here I made write like that. Then PR is, or we can say here at Q. Okay. And PR is perpendicular to line AC at R, and PS is perpendicular to line AB at S. Then QRS are collinear. I am not mentioning their betweenness. That betweenness may vary as P varies. So this line is termed as the Simpson line, not necessarily QRS. It can be QSR or whatever permutations we have. Okay, so how to prove? I think Raghav put the proof very simple manner that we consider the cyclic quadrilaterals and then we are done. Actually, we just need to show here our idea is that I may call it as idea 1, which is very typical and obvious idea that we use to prove angle PRS plus angle PRQ is a straight angle, that is 180 degree. If we are able to do that, then we are done. Okay, and for that we use cyclic quadrilateral ASRP. According to this configuration, ASRP, sometimes it may come like SARP, because if S is not between A and B, then it is SARP also. So it depends. Then, yes,
we
you
can
didn't raise the
assume,
hand, but you started speaking. It's okay. Go ahead.
so we can assume without loss of generality that P is in the arc AC. So that is simpler.
No. We can consider any. So without loss of generality, it's okay. And if say P is very simple, if it coincides on any of the vertices of the triangle, then what?
Then it's sort of trivial because the perpendicular
Yes.
to the line BC and AC, if P is equal to C, is
Yep.
C itself. So whatever the perpendicular on B is, let's say S, obviously CS is
Yeah.
collinear.
So the altitude from C would be the Simpson line in that case. Am I right? If
Yes, sir.
P coincides C, then altitude from C is the Simpson line. So that's a trivial case but obvious case. And yeah, we can say that without loss of generality, we consider P on minor arc ABAC. That is also, so here, yeah, I didn't mention, but we can say that here without loss of generality, WLOG without loss of generality, that P belongs to minor arc AC of circumcircle. Okay, so without loss of generality, we consider that P belongs to minor arc AC of the circumcircle. You can consider anywhere. Okay, so we consider the cyclic quadrilateral ASRP and cyclic quadrilateral. We have like there are many cyclic quadrilaterals. PRCQ also. PRCQ. Yes, is there any more cyclic quadrilateral that we can get? From B, we have
ABCP is a cyclic quadrilateral.
which one?
ABCP by construction. ABCP.
ABCP. Okay,
Yeah, by
yeah, that,
construction.
yeah. So there are so many cyclic quadrilaterals. So we can have cyclic quadrilateral like I am just naming them like BSPQ also. We have cyclic quadrilateral APCB. Okay, so many cyclic quadrilaterals are there. Okay, now you try to do some angle chasing in that. I am not going to give a whole idea. Okay, so I just mentioned the names of these cyclic quadrilaterals. If there are other than them, you can find out and get the proof for this. Okay, and it's converse that in this converse, what we take, this will be our hypothesis of this will be our hypothesis, and this will be our conclusion that P belongs to the circumcircle. Okay, so its converse goes like, and because of the perpendicularity, we can have cyclic quadrilateral except this. Then we need to show APCB is the cyclic quadrilateral in that. So if you want the converse, that if P belongs to the circumcircle, oh, sorry, I'm wrong in writing. Sorry for that. So PQ is perpendicular to BC at Q. PR is perpendicular to AC at R. And PS is perpendicular to AB at S for triangle ABC. Such that QRS are collinear. Then we say that P belongs to the circumcircle of triangle ABC. So in that, we just need to show this triangle is, sorry, this quadrilateral is cyclic, APCB, then we are done. Okay, because of the perpendicularity, we have those cyclic quadrilaterals, and then we try to figure out that angle APC is 180 minus B, or APCB, or whatever the name comes according to the point P where we consider, then we can show it easily. Okay, so that is what our Simpson line. So our first question can or gives us some ideas related with that. Okay, so I think you might have got these things. If you have questions, then very few persons are interacting. I think, or I hope that more persons should take part in the interaction, so that different ideas will come out. And if after this is our first session, I would like to listen your feedback to me on the mail, that if you are considering that, sir, I don't have this much stuff with me, I am not understanding, then we will figure it out that how to make the things better. Okay, so don't take tension that if 2-3 persons are taking part and others are, oh, what is going on, oh, I am not understanding what is going on, what should I do, I will quit. Don't do like this. Get it and start working. If you feel, oh, something is missing, then try to interact with me, and I will try to just give you some guidelines, some more stuff, some prerequisites. Okay, so over the time you can make it sure that you are learning that stuff and going ahead. So for others, those who were not speaking up, then for those persons, I am just giving you the notice that don't take tension. If you feel that something is very much higher, or what concepts I am considering are obvious but not for me that obvious, if you consider like that, then better you open up and send me the mail that, sir, I found it difficult, so what should I do, what are the suggestions, what kind of stuff I should read, and in what sequence I should read, then I can guide you in that part. Okay, yes, so going for our second question. Shreyan is asking that in general, are most proofs based on cyclic quadrilaterals, as that is something I have seen a lot. I think yes. See, mainly we need the similarities or angles chasing like part, then we use cyclic quadrilateral. And in this worksheet, I intentionally included a major part of cyclic quadrilateral, because in regular school studies, we deal with the things which are coming before the cyclic quadrilateral and their properties. So I tried to give those questions. And in exam also, maybe, I can't guarantee yes or not, but it may. depend. Okay. Yes, I think. So this is the question that it is read as circle with center O1 and radius R1. How we read it? This is a shortcut symbol. Circle with center O1 and radius R1 and circle with center O2 radius R2 intersect at P and Q. If O1P extended intersects circle with center O2 and radius R2 at B, O2P extended intersects circle with center O1 and radius R1 at A, then we need to show that O1, O2, A and B are concyclic. That is what our problem. Okay. So yeah, Atharva has answer maybe, but I think I must draw the figure first and then we will see what our friends want to add on. Okay. So let's draw the figure that circle with center O1 and radius R1 and there is another circle. This is O2. This is O1. This is P. This is Q. O1P. O1P intersects in B. O2P intersects in A. And now we need to show that the quadrilateral O1, O2, BA is a cyclic quadrilateral. Okay, no, it is not for homework. Just we will discuss. Yeah, I am taking in sequence as it is our first encounter. Okay, yes. So, yeah, two persons are ready. Mere angle chasing will help. It is very simple. Okay. I think, yes, Raghav.
So should I give the solution?
No, can you give the hints for solution? What ideas you are just giving here?
Sir, only isosceles triangle and vertically opposite angle.
Oh, yes, you are right. Very good. Isosceles triangles. Oh, sorry. Isosceles triangles. Then vertically opposite angles. And then the part that if a line segment subtends equal angles at two different points at the same side, then suppose these are X, Y, Z, W. So XY subtends equal angles at W and Z and the same side of it, then those points, 4 points are concyclic. We use this idea. Okay, good. Yeah, Kriya, what you want to say?
Actually, it's the same idea, sir. So
Great,
also the same idea.
good. So Atharva is asking where we are going to get the isosceles triangles. Nice. Radii of the same circle are equal. Okay, radii of the same circles are equal. So we have that triangle. Sorry. Yes. So triangle O1AP is isosceles because O1A is equal to O1P, radii of the same circle. So angle O1AP is equal to angle O1PA. Say it as number one. Then triangle O2PB is again isosceles because the radii of the same circle, O2P and O2B. So we have angle O2PB is equal to angle O2BP. Say it as number 2. Moreover, we know that APO2 and that is a straight line. Moreover, BPO1 is a straight line. So we have, we can say that as lines APO2 and BPO1 intersect at P. Therefore, angle O1 PA is equal to angle O2 PB because they are vertically opposite angles. So from 1 to 3 and by transitivity, from 1 to 3 by transitivity, we have angle O1 AP is equal to angle O2 BP. But because these are the straight lines, so we say that angle O1 AO2 is equal to angle O1 BO2, and then we use this idea and we are done. Okay, transitivity is that suppose there is some relation. Okay, I will show that relation that by some different sign. Suppose I have relation between A and B, say relation is asterisk. There is relation between B and C. Then I have relation, the same relation between A and C. So this is known as transitivity. Okay. And then I use the same part over here. Okay. So equality is transitive relation. So we use the transitivity over there. That is multiple ways of multiple times transitivity is used. Okay. So I think it is more than sufficient for today. There are more stuff for you. You can go ahead. Okay. Is it still cyclic if we have O2Q instead of O2P? O2Q, yes. But for that, we need to draw the figures, the straight lines. Yeah. Yes, Atharva, you want to say anything?
Sir, how much should we do by next class?
Pardon?
How much of the sheet should we do next class? The worksheet?
No, I am not getting you. What are you stating?
How much of the worksheet should I complete before next class?
Yeah, you can, as many as you can. And so we will deal some with typical. Yeah, I think 9th question is misprinted in that. And in 3rd question, there is a correction that I can show you the correction in 3rd question. Here is the correction. AD. AB equal to AD. So I printed over there CD, which is not possible. AB equal to AD is the correction. And in 9th, I missed one line. So I am not ready to figure it out immediately now. So I am not telling you about 9, but 3rd is here mentioned. Okay.
So where should we submit our answers? Where should we submit our answers?
Whenever you get time.
No, so where do we submit? Like on the classroom?
I think it is better to send me by mail.
Oh.
Yeah. Okay. Yes, Shreyan?
So how do we show that it's still cyclic or it's not still cyclic if I use O2P instead of O2Q? Because by O2Q, I mean when we say the O2P intersects with circle 1 at A, I mean if we say O2Q intersects with circle circle 1 at A.
Yes.
Because
yeah. We need to consider this.
Yes. I'm not saying I'm not talking about a thing. I'm just saying that they are on the opposite. So I'm saying B is from O1P and A is from O2Q. Because first time I tried to solve this question, I misread. And this is what I was trying to solve. At A and B are at opposite sides. So how would we do it in that case?
I think it is said that O2P extended. So O2P extended will meet at A to the other circle, obviously.
Other side of the circle.
See, when we say circle, we consider its edge. Okay, circle is a ring and its inside is the circular disc. When we say it cuts the circle, then it is always on the circle.
What I mean by that is, can you first label the two blue points?
Yeah, we can say them as here C and here D.
So I was saying, how would you prove or how would you disprove that A O1 C O2, I mean B O1 C O2 is cyclic?
Yes, in the same way.
So, B O1 C O2, that's a different question completely.
D01 C
B01 B for आपका नाम B.
D for dog.
B for आपका नाम B.
B.
B01 CO2.
B01
CO2.
CO2. Okay,
So
are they cyclic?
Because that was what I first misread the question as.
Oh.
So how would I solve this question instead? Because I said this question.
Why did you consider this? I think I have a question first, that because it is said O1P and O2P are extended. So why did you consider O2Q?
Because I misread it. I misread it as O2Q.
Okay. I think we need to think whether they are cyclic or not, because BO1, CO2, not necessarily, I think so. No. And if so, then that would be a special case. Here, I think I am not finding them cyclic.
Why is it not cyclic?
See, if they are cyclic, then you know that opposite angles must be supplementary. Then you try to see the angles are supplementary or not, because you mean that that quadrilateral would be like this as BO1 CO2.
So you are saying that they are the same instead of being supplementary. So if it's not 90, it's not cyclic.
Yeah, if they are cyclic, then they must follow the properties of cyclic quadrilateral. And if you make some angle chasing, and if you find that yes, they are, then it's okay. If not, then I think you make some angle chasing by considering the angles, and then I think you will find that whether they are cyclic or not.
Okay, sir. Thank you.
Okay, yeah, because see, the positions of O1 and O2 are different. So maybe I think not. They are not. Okay, so Atharva has put the mail ID in Google Classroom so that you will get that. Okay, so I think for today it is more than sufficient. So next time we will see. Till then, we should say bye-bye and thank you.
Bye, sir.
Yes, sir.
Yes,
Thank
bye-bye.
you, sir.
Good night.
Bye-bye.